Hi, welcome to today's video. What we're going to be looking at today is properties of the gradient. Okay, this is where they can actually make properties of gradient. I can't multitask. Okay, so I cannot tell you what is going to happen while I'm writing. I'm a guy. Alright, so properties of the gradient. This is where they can actually give you some properties of the gradient and ask you to find a line based on those properties. Now, you should have watched how to find the gradients, okay, because I spoke about parallel gradients today. I'm going to use one of those. And you should have also watched the gradient inset method. That also helps quite a bit. Okay, now there's two things that you want to talk about initially. Okay, when you start to get into much more involved things, you start to look at talking about the gradient in terms of tan of the angle it makes with the x-axis. We're not doing that here. What we're looking at is two simplistic things. Firstly, parallel lines have the same gradient. Okay, I said that in the previous video. And also, the main one here, perpendicular lines have negative reciprocal m values. Ha! What does that mean? Okay, well, let's do one and I'll show you what it means. Okay, so e.g. And the story is, write down the equation 90 degrees to y equals 3x plus 1 that passes through 0, 4. Okay. Now, from the previous video, you should all be going, "Wow, look, sir! Look! That is the y-intercept. That is the y-intercept. Why is it the y-intercept? Because that's 0. Y-intercept. Okay. Always identify it. As soon as you see 0 in the x value, that's got to be the y-intercept. Okay. Makes your life a little bit easier. All right. So now, let's look at what a perpendicular line means. If it's perpendicular, all right. Actually, I want red for the gradient. If it's perpendicular, okay, that means that this times its negative reciprocal, the two gradients times each other. So the gradient of this, let's call this 1, gradient of 1, times the gradient of 2, which is the one you want to find, has to equal negative 1. Okay? So, here I'm going to do the working, then I'm going to show you a shortcut. So the gradient of this is 3, times by some other gradient, the one you're looking for, equals negative 1. Well, it's the opposite of times by 3, it's divided by 3. The gradient equals negative 1 divided by 3. Okay, so that's the long-winded story about this. The shortcut is I say, take this thing, turn it into a fraction, flip it, and change the sign. Now, I don't say make it negative. I say change the sign, because if it is already negative, then it becomes positive. Okay, so take this. Okay, I'm not putting equals because they're not equal. Flip it, and change the sign. If this was negative, it would become positive. That's it. Take your gradient, flip it, and change the sign. Okay, that would give you the negative reciprocal, 1 over whatever it is, the negative reciprocal of your gradient. Those two gradients, negative a third and 3, are perpendicular to each other. Okay, so one of the properties of gradients you need to remember. Okay, well, I've got my gradient of my new line, and now I'm going to say, okay, well, where's it going through? Well, it's going through my y-intercept of 4. So we're done. We have that. The gradient now, the equation equals, y equals, well, the gradient is negative a third, negative 1/3, and whether you put the negative in the 1, or the negative in the 3, or the negative floating in front, it doesn't make a difference. Negative 1/3 x plus 4. Plus 4. That's it. Piece of cake, huh? Okay, so the only thing you really must remember when you're talking about perpendicular gradients that are 90 degrees to each other, okay, is this negative reciprocal. Another word for perpendicular is orthogonal. It's an old-fashioned word. Well, it's an old word that they used to use when I was in the school, so, you know, way back when, in the dark ages. So if you ever see the word orthogonal, okay, it also means perpendicular, 90 degrees, so you wham bam do this one as well. Okay. Alrighty, let's take a look at two other quick examples, okay? But that was the main one for this thing. Let's just quickly look at two more. Okay, so e.g. write down the equation that's parallel to 3x plus 1 but cuts the y-axis at minus 2. Then one parallel to y equals 3x plus 1 but cuts the y-axis, y-intercept at minus 2. Well, this is no working involved. This is just theory. Parallel, same gradient, y equals 3, same gradient, x, cuts the y-axis at minus 2, minus 2. That's it. No working involved. Just understanding what it means. Parallel lines have the same gradient. If you don't believe me, go plot a couple of parallel lines. So take some graph paper, draw out some coordinates, okay? Do 2x plus 5 and 2x minus 2. It'll do 3x plus 1 and 3x minus 2. It doesn't make a difference. As long as the m value, the gradient in front, is the same. Plot those points and you'll see you'll get beautiful parallel lines. Okay. Alright. If you don't, you probably made a mistake with the plotting. Okay. But I trust you. I think you'll be able to do it. Alright. So, let's try another one. The only way they can actually slightly make this even a little bit more tricky is they say this. Write down a line parallel to 2y minus 3x equals 4. And passes through the origin. So passes through the origin. Alright? Now, for those of you who don't know, the origin is the name for the center of the xy axis. The coordinate 0, 0. So the origin has a coordinate 0, 0. You're expected to know that. Okay? Alright. So, all that we're going to do is, first thing, okay, that's not my gradient. I get this a lot, okay? Kids see this and they say, okay, cool, the gradient's a number in front of x. No. The gradient's a number in front of x when it's in standard form, meaning when y is alone. Right now, y is not alone. So let's get y alone. How are we going to get y alone? We're going to go bit mass, backwards, and opposite to other side. Alright, so I said, okay, great. Let's do this. What's happening to y? It's being times by 2, then minus 3x. So let's get rid of bit mass backwards. We reverse this. Let's get rid of addition or subtraction before multiplication or division. So opposite minus 3x is plus 3x. So I've got 2y equals 4 plus 3x. I don't like writing 4 plus 3x. I like the x's in front. Okay? So I'm going to change that on the next step. Now I can get rid of the times by 2. Y equals 3x plus 4. I've just rewritten the order of this. Doesn't make a difference. Divided by 2. That's not nice because we like mx plus c. To split a fraction, any fraction where it's got 2 terms in the denominator, or 2 terms in the numerator on top, or 3 terms in the numerator, okay? All you do is you give each term its own denominator. So to split this, I've just got 3x over 2 plus 4 over 2. That's still ugly. Let's tidy it up. Y equals 3 over 2x, or you can write 1.5 if you want, plus 4 divided by 2 is 2. There it is. Okay. Alright. Well, what have I done? All that I've done is I've got this into standard form. But now I'm going to actually answer the question. So I'll answer the question in blue. They said, write a line that is parallel to this, parallel, 3 over 2, right? So it's got to have the same gradient. I'm going to carry on here. Y equals 3 over 2x. Parallel to that, and passes through the origin. So passes through the origin, so y-intercept, oh look, x is 0, so that must be my y-intercept. So my y-intercept is 0. So if you want, 3 over 2x plus 0. But plusing 0 does nothing to anything. So why waste your ink writing it? Y equals 3 over 2x. Finished. You with me? Okay. Just remember, please, just remember, this here requires an extra step. You've got to get it into standard form. Then our rules with gradients all work. Parallel gradients, there's my gradient, 3 over 2. Okay, 1.5. 3 is not my gradient here. 3 over 2 is my gradient. Okay, then my rules with gradients, with orthogonal gradients all work. By the way, this is not on the notes, but if I wanted to say a perpendicular line to this that's passing through here, well, very quickly, flip and make it negative. Y equals 2 over 3 negative x passes through 0. Okay? Or passes through 5. Plus 5. Doesn't make a difference. Okay? When you understand this, it starts to become really quick. But the ideal that I think is to understand what different parts are. What is the gradient? What is the c value? How does it all come together? Okay? Go practice this. Go choose a couple for yourself. Maybe get a graphing program, okay? Some graphing software. There's lots of graphing software out there. Go look for some on the internet, download a free trial, and give it a shot. Okay? Anyway, remember, I'm here for you.